The lecture you are about to see is part of our annual Alan Edwards Psychology Lecture Series. Professor Edwards was affiliated with the Department of Psychology for half a century until his death in 1994. He was an outstanding teacher, researcher, and writer who introduced new statistical techniques that are credited with changing the way modern psychological research is conducted. Alan also permanently enhanced the intellectual climate at UW Psychology by endowing the Alan Edwards Lectureship, which since 1999 has brought in an impressive list of renowned psychologists to the UW campus to interact with faculty and students. The lecture you're about to watch is one of a pair given back-to-back that matched a UW psychology professor with a visiting researcher to talk about a topic of great public and scientific interest.
Good evening. My name is Sherry Mizumori, and I'm the chair of the psychology department. And tonight I have really the distinct honor of welcoming you to the 5th annual Alan L. Edwards Public Lecture Series. And I'm pleased that you could join the psychology department tonight as we celebrate one of our research specialties, again, and that concerns the development of behavior. Now, before introducing the evening lecturers, let me just say a few comments to let you know how we got to where we are. This truly exciting annual lecture series is the result of generous support of one of our former faculty members, Professor Alan L. Edwards. And he made a substantial gift to establish an endowment that ensures that this series takes place free of charge to all of you into perpetuity. Now, the Edwards family contributions to the psychology department is an example of what can be accomplished with the support of members of the community, such as each one of you in this room as well. Thus, especially in these tough economic times, your support has been very much appreciated and is critically important. So again, thank you. Now, the psychology department seeks to take advantage of its unique collection of world-class researchers and instructors by facilitating the interactions between the traditional subdisciplines in psychology, for example, the areas of clinical psychology, developmental, cognitive, behavioral neuroscience, social, and animal behavior. We aim to foster a new synergy that leads to innovative solutions to large societal problems. This year's focus on the development of behavior exemplifies our department's unique type of interdisciplinary and comprehensive research programs that use a variety of tools such as behavioral assessments, neuroscience methods, ethological analysis, and developmental theories to advance our understanding of the development of normal and abnormal psychological functions. So you will see that such a comprehensive understanding is essential for the development of effective educational tools and therapeutic interventive methods for our children. Now, tonight we're quite fortunate to have leading developmental psychologists that will discuss how we come to interpret the behaviors of others in terms of their goals and intentions. A rather simple sounding process on the surface, but it ends up being quite complex and very fascinating, as you'll see. Now, Jessica Sommerville is our speaker that I'd like to introduce at this point. She's in our department here at the Department of Psychology at the University of Washington. She received her Bachelor of Science degree in Psychology from the University of Toronto in 1997, a Master's degree in Psychology from the University of Chicago in 2000, and then her PhD in Developmental Psychology also from the University of Chicago in 2002. She was a preceptor in the Masters of Arts program in the Social Sciences at the University of Chicago from 2001 to 2. She then moved here to the University of Washington as a postdoctoral fellow in the Center for Mind, Brain, and Learning from 2002 to 2003. And then she joined the faculty in the Department of Psychology in 2003 as an assistant professor. And just this past year, in 2009, she was promoted to associate professor with tenure. Now, Dr. Sommerville is considered a trailblazer in research on the development of one's understanding of the behaviors of others during social interactions. She's received numerous forms of awards and recognition from professional and academic organizations, including the National Academy of Sciences, the University of Chicago, and the National Sciences and Engineering Research Council of Canada. Dr. Sommerville is on the editorial board of high-profile scientific journals such as Developmental Psychology and Infancy. Her work is supported by the National Institutes of Child Health and Development, as well as by the University of Washington Royalty Research Fund. The amazing findings that you'll hear about tonight have been or stem from work that has been published in top journals such as the Journal of Cognition and Development, the European Journal of Social Psychology, Cognitive Development, Developmental Science, and many more. Dr. Sommerville also presents her work at invited addresses, research talks, and workshops around the world. So it's with great pleasure that I introduce Dr. Jessica Sommerville.
Well, thank you, Sherry, for that very generous introduction, and thank you all for coming this evening. So the title of my talk this evening is Understanding Goals and Intentions in Infancy, Developmental Mechanisms. And before I begin, what I'd like to do is acknowledge some of the individuals who have been key players in the research that I'm going to tell you about tonight. Some of you might already know this, others of you might not yet know it, but doing infant research requires a lot of resources. It's very, very time consuming. It takes a lot of very hardworking people to do the work that we do. And so I'm lucky to have in my lab a number of hardworking staff and students who have contributed to what you'll hear about this evening. And in particular, I'd like to acknowledge two graduate students, Emily Blumenthal and Chung-Eun Yoon. They're in the audience this evening, and they were intensely involved in the studies that you'll hear about towards the end of my talk. I'd also be remiss if I didn't thank our infant participants and their parents for generously devoting their time. We couldn't do our work without them. And without them, we wouldn't be able to unlock the mysteries of the infant mind that I'm going to tell you about this evening. So without further ado, as adults, we're experts at identifying other people's goals and intentions. And the ability to understand other people's goals or intentions is actually central to many aspects of mature social behavior and mature cognition. It not only informs our understanding of individual behavior and interpersonal interactions, but also allows us to understand group events like sporting events. So if we didn't understand goals or intentions, we'd have a hard time figuring out what's going on here. We wouldn't understand that Rebecca Johnstone is trying to take a shot on goal and secure a win for Canada. I'm Canadian. Understanding goals and intentions also guides learning across a range of different domains. So in order for us to learn from other people, we have to understand at some level what it is they're trying to teach us. And that's why we as college instructors are often encouraged to form learning goals or share learning objectives with our students in order to facilitate the learning process. In addition, identifying other people's goals and intentions is critical to the judgments that we make, both as individuals, as a group, at a societal level. So making judgments about someone's presumed guilt or innocence in a legal case often hinges on what we think the individual's intent is. So some of you may recognize this picture. This is Susan Polk, and Polk was charged with first-degree murder for killing her husband. And this is a highly controversial case because what it hinged on was what her intent was. Was her intent to defend herself? Was it self-defense? Or was her intent more malicious? Did she intend to try to gain financial control of her husband's estate? Finally, deficits in the ability to understand goals and intentions are thought to underlie a range of clinical disorders such as autism. So by understanding the typical course of development, we have the opportunity to intervene when development goes awry. The research that I'll talk about today suggests that, like adults, infants spend a lot of their time thinking about and trying to figure out other people's goals and intentions. And there are important, rich changes that go on in this ability over the first year of life. So in my talk today, I'm going to talk about 3 sets of studies. I'll tell you about some research that suggests that within the first 6 months of life, infants start to understand the goals of simple actions like reach and grasp events. I'll also tell you about studies that suggest that several months later, infants come to understand more complex action sequences, like the one you see here. So in this sequence, an actor is pulling a cloth in order to bring an out-of-reach toy that the cloth supports within reach so that she can get the toy. Now, to understand this sequence, infants have to understand that her actions on the cloth are a means to an end, that they are about the achievement of getting the toy and not about the cloth. And I'll also discuss some work that suggests that towards the end of the first year of life, infants are starting to understand goals in a more richly psychological sense, in terms of the personal preferences that people possess. Now, over the first year of life, we know that there are a number of other important developmental achievements that occur. So by about 6 months of age, infants get really good at reaching for objects. several months later, they start to perform more complex action sequences. So an infant by roughly 10 or 11 months is starting to be able to pull a cloth to retrieve an out-of-reach toy. And finally, towards the end of the first year of life, we see developments in infants' language understanding and ultimately in their language production. And in my talk today, I'll be arguing that each of these developmental achievements plays an important role in the changes that we see in infants' understanding of actions over the first year of life. So in the first two studies, I'll talk about how infants' ability to perform simple actions and then action sequences help them to understand other people's actions. And in the third set of studies, I'll discuss how infants developing language comprehension abilities, their ability to understand language, plays a role in their understanding of other people's preferences. Now, one of the first questions that you might have is how can psychologists determine what young infants are thinking and what young infants understand? Of course, we can't use a lot of the experimental paradigms that are commonly used with adults. We can't sit an infant down and ask them complex questions about their thinking, right? They just won't respond. Infants aren't particularly good at filling out surveys or rating scales. They also don't produce highly sophisticated motoric responses, so we can't just give them a computer keyboard. But one thing that infants are really good at doing is they're good at looking at things. And for those of you that have watched infants, you've probably seen infants often showing intense interest in different events that are going on in their environment. So developmental psychologists capitalize on infants' looking behavior, that is, how long they look at things and where they look at things, as a means to try to figure out what they know and understand. And in fact, there's a general principle that guides attention, not only in infancy, but also in childhood and adulthood. And I'd like to illustrate this principle by having you act as an experimental participant in one of our studies. So what I'm going to do here is I'm going to show you a series of images, and I'm going to be attending to how long you look at these images. So this is the first image. You're going to probably start off by thinking this image is somewhat interesting. Maybe you've never seen it before. Maybe it's a novel toy for you. And if I was watching your eyes, I bet I would see that they were scanning the image, looking at different parts of it. Okay, this is the second trial of our experiment now, and this is the same image that you've just seen. You probably recognize it as the same image you've just seen. And as a result, the image isn't as interesting as the first time that I showed it to you. Here we go again, the same image. Now the image is probably not doing a great job of holding your attention. You might be getting antsy in your seat, starting to fidget. Maybe some of you are turning to your neighbors. I see some people in the back doing that. And finally, the same image, and you're probably starting to think to yourself, how many more times are they going to have to see this boring old image, right? Maybe some of you are checking your text messages on your phone. So that's how I know that you're bored. And this phenomenon, that is this decrease in attention, decrease in looking to a repeated stimulus, is called habituation. Okay, so here comes the next trial. So here's a new image. You're probably feeling somewhat relieved. You say, okay, thank goodness I get to see something different. Your interest is going to perk up. You're going to spend longer looking at this image. And this is called dishabituation. So dishabituation is the recovery of attention, or in this case, the increase of looking to a novel stimulus. Now, what I've just learned from your behavior here is that you can discriminate the two objects that I showed you. You can tell the difference between the red toy car and the green frog. Congratulations. Okay, so the next experiment I'll ask you to participate in takes this method and extends it to ask a different question. So now the question is, when I show you this particular object, what do you think is so important about the object? What is it that you're focusing on about the object? And what I want to know here is I want to know if you think the size of the object is more important or whether you think the shape of the object is more important. Okay? So again, I'm showing you this image. You're looking at this image. Here it comes again. Okay, you see the image again. Again, you're probably getting less interested. You've already seen this orange circle before you recognize it. One more time, and again, it's getting pretty boring, right, by this point. You're not so interested anymore. And so I'll spare you the remainder of the habituation trials. We'll fast forward to the test trials. So here's the first test trial, and what I've done is I've made a change here. I've changed the shape of the object. It's still orange. It's still roughly the same size as the first circle, but it's a different shape. Okay, and here's our second test trial. This is another new event. This time I've changed the size of the object. So now it's smaller than it was before. Still a circle, still orange. Now the idea here is what I'm going to do is compare your attention to these two test events, how long you look, as a means to telling me what you think is more important. Is the size or the shape more important? So here's a graph of your hypothetical looking times. So the y-axis is telling us the average audience members' looking times in response to the two test events, the orange square and the smaller circle. And what we can see from our graph is that the change in the shape of the object was more interesting than the change in the size of the object. So based on that, we infer, well, obviously you think shape here is more interesting than size. So this is the logic that underlies a lot of the studies that I'll tell you about today. We start off by showing infants a simple event, and then we change one dimension versus a different dimension of the event. Based on how long infants look at those two different changes, we make an inference about what they think was important about the initial event. So now you might be wondering, okay, so how does this play out when you bring an infant to a lab? Into the lab? What does that actually look like? So I'm going to show you a short video clip of a single trial from a study. What you'll see on the left-hand side of the screen is you're going to see a live event that the infant is watching. It's presented on puppet stage. And the black screen that you see here is the screen that can be moved up and down to either hide the display from infant's view or show them the display. On the right side of the screen, you'll see what a trained observer, a trained experimenter in our study would see, and that is the baby's face. And what the experimenter is doing here is they're using a computer program to code whether the infant is looking at the event or away from the event. So let's watch. The actor is sitting between a green frog and a red car. The actor looks at one object, she looks at the other object, she says, "Look, wow," and she picks up her desired object. That's the live event that the baby's watching. And then she pauses, she holds that pose. And the infant looks at the event for most of the time, occasionally looks away from the event. What the trained observer is waiting for, what the computer program is actually waiting for, is they're waiting for the baby to look away from the event for 2 consecutive seconds. That's the computer program saying, okay, the baby's bored, they've looked away for 2 seconds, and you would see the screen come up. And what happens in our studies is we start by showing babies the event on repeated trials, and then we show them novel events, and we're timing how long they look at these events. Okay, so that brings us to our first study. When do infants understand the goal of simple actions? In order to address this question, in the late 1990s, Amanda Woodward came up with an ingenious paradigm. And it capitalizes on the general logic that I told you about earlier. In her paradigm, she showed babies a simple event. And what they saw is they saw an actor reach onto a puppet stage and grasp one of 2 toys sitting side by side. And she timed how long babies looked at that event. Now, to adult eyes, when we see this simple event, we tend to think about it in a particular way, and we tend to focus on some aspects of the event over and above other aspects of the event. So if I were to sit you down and ask you to tell me what's happening here, or ask you to write a verbal description, you'd probably say something like, she wanted the bear, she grabbed the bear. So what you'd be focusing on in all of these descriptions is the goal of the event. In contrast, it's highly unlikely that you would say something like, well, she reached to the rightmost part of the display, her arm moved at a 45-degree angle and at roughly 5 centimeters per second, and she contacted the object with 4 fingers, right? Those aren't the things that we think are important about this event. It's the goal that we think is important. So to ask whether infants also shared this understanding of this very simple event, what Woodward did is she showed infants this event on repeated trials. She recorded how long they looked at the event. And unsurprisingly, with each repeated presentation, they recognized the event. They got bored over time. And once they got bored, what Woodward did is she hid the display from infants' view. And she made one critical change to the display. She simply reversed the locations of the toys. She put them in their opposite locations. This enabled her to show infants 2 different test events. In what she labeled the different goal, same movement test events, the actor reaches in and grabs onto a different goal, a different object than she had before. But of course, all of the other properties of the event are the same movement as infants saw during the habituation event. Now, the idea here is this event is the one that adults would find interesting because the actor's goal has changed. And she contrasted that event with another test event in which the actor reached in. This time, the arm followed a different path of motion, produced a different movement. But the actor went after the same goal that she had initially. Her goal is the same. So adults presented with these events would say, hey, this is the interesting one. Her goal has changed, the one on the left-hand side. The one on the right-hand side is not so interesting because I don't care so much about those other properties of the event. So the idea here was that by looking at infants' respective attention to these two events, how long they looked at them, she could make an inference whether infants shared adults' understanding. So this is what this research revealed. It revealed that at 3 months of age, infants do not discriminate between these test events. They look equally long to both of those changes, so they didn't appear to understand the event in the way that adults do. By 6 months of age, infants look longer to the change in the goal of the event than the change in the movement of the event. And what these suggested is that by 6 months of age, infants are understanding this very simple event in terms of the actor's goals. And also that there's a critical developmental change or transition that happens here between 3 and 6 months of age. The next question that we asked was how infants develop this understanding. And we know that between 3 and 6 months of age, infants get really good at reaching for objects on their own. A 3-month-old might swipe at an object or bat at it, but they're probably not going to produce the smooth, well-executed reaches that a 6-month-old produces. 6-month-old is good at reaching for objects of different sizes and shapes, at recognizing objects that are within reach versus outside of reach, and can reach under varying lighting conditions in the light and in the dark. And so the question that we had was, does this developing ability to reach help infants understand another person's reach and grasp? Okay, so to address this question, we tested a group of 3-month-old infants. And remember, because these are 3-month-old infants, they're pre-reaching. They're not good at reaching for objects. And we tested them in a habituation paradigm that was very similar to the Woodward paradigm. So just to remind you what infants saw during the habituation trials is they saw an actor reach onto a puppet stage and grasp one of 2 toys. And we showed them that event repeatedly until they got bored. And then on the test trials, we showed them events in which either the actor's goal had changed and the movement was the same, or the actor produced a different movement but was achieving the same goal. So the idea here is if infants get this event, if they understand it, they should look longer at the different goal, same movement event than the different movement, same goal event. Now, of the 3-month-olds that we tested, half of them received only this paradigm, only this habituation paradigm. Another half of infants took part in that visual habituation paradigm, but before they did, they took part in what we called the sticky mittens task. And the goal of this task was to take the 3-month-old infant, who is not good at reaching for objects on their own, and pump them up, get them better at reaching for objects. And of course, in order to do that, we had to rely on some creative means. So what we did is we took some little baby mittens, and we created miniature replicas of the toys that were used in the habituation paradigm. And we put Velcro on the mittens, and we also put Velcro on the toys. And what this meant is that when 3-month-olds flailed their arms around and happened to make contact with the toys, all of a sudden they could apprehend them, they could move them around, and they could pick them up. So what I want to do is show you a little clip of that. In the sticky mittens task, we actually started out with a no mittens phase where we just gave babies the toys. They, of course, weren't very good at reaching for them, and then we gave them the mittens phase. Okay, so here's an infant in our study working with the mittens on. Remember, this is a 3-month-old pre-reaching infant, so without the mittens, they wouldn't be very good at reaching for the objects. So infants were really fascinated with this test. You can see the look of concentration and intensity on their face. Over time, they got a lot better at putting their hands on the objects. The problem with these mittens is they don't have a quick release button, so it's a lot of work for the experimenter, too.
Amazing.
So looking at the teddy bear now. And success. Okay, so that was the sticky mittens task. So what I want to do now is show you the results from our infants. Remember, there was one group of infants that only took part in the visual habituation paradigm that assessed their understanding of the reach and grasp event, and another group of infants who got the sticky mittens task first and then took part in the habituation paradigm. So these are the watch first infants, and what this graph shows you is infants' average looking time to the two different test events. Beside the title, what you'll see is the habituation event, and we have plotted here the test event where the actor's goal changed and the test event where the movement changed, but the actor's goal remained the same. And what you can see is that for the watch first infants, these infants who didn't get any experience reaching for objects, they didn't discriminate between the two test events. So in the absence of reaching experience, they didn't really understand what was going on here. They weren't selectively focusing on the actor's goal. Now here's our other group of infants. These are the ones that got the sticky mittens task before the habituation paradigm, and they showed a different pattern of results. So same graph. Infants in this group looked significantly longer when the actor's goal had changed than when she'd produced a new movement. And what this suggested to us is that intervening to improve infants' ability to reach for objects had consequences for their ability to understand another person's reach and grasp. That is, helping infants reach and grasp helps infants to understand another person's reaching and grasping. Okay, so back to our timeline. Just told you about infants' understanding of simple reach and grasp actions. And what I want to do now is talk to you about how infants develop the ability to understand action sequences. The next question that we had is, what if we take this situation where someone reaches for an object and we make it more complex? So now we take the object and we put it out of reach on a cloth so that the actor has to pull the cloth to get the toy. So to adult eyes, this might seem like not a very big change, right? You've just kind of added a step here. But to infants, this is a wildly different situation. And the reason that it's a wildly different situation is this now is a means-end sequence. The actor has to produce a means in order to obtain an end. So infants have to understand that the actor is grasping the cloth, not because their goal is the cloth, but it's just a way for them to get the toy. So in this study, we tested 10 and 12-month-old infants. And again, we used a visual habituation paradigm to figure out how infants were thinking about this action sequence. So in this paradigm, what happened is there was an actor who was sitting behind a stage, and the stage supported two different colored cloths, and they had out-of-reach toys on them. The actor pulled one of the cloths, brought the toy within reach, and grasped the toy. And we showed infants this event on repeated trials again and again until they got bored. Our question here was whether infants would recognize that when the actor was pulling the cloth, she was doing so in order to get the toy. She wasn't really interested in the cloth itself. So when the display was hidden from view, we switched the locations of the toys, and we showed infants two test events. It follows the same structure as the prior study. So in the different goal event, same means, the actor is pursuing a new goal. But the way she's pursuing it is the same as she was previously. In the other event, the same goal, different means event, the actor has the same goal as she had initially, but she's using a new means to accomplish the goal. And again, to adult eyes, what's really interesting here is the change in the goal. Because we understand that the reason the actor's pulling the cloth is in order to get the toy. So the question is whether infants share this understanding. Here's the data for 10-month-old infants. Again, this graph shows you their average looking times to the test event. Habituation event is in the upper right-hand corner, and the red bar signifies the change in the actor's goal. The yellow bar signifies the change in the actor's means. What we found is that 10-month-olds as a group looked equally to the test event. They didn't distinguish between these two different changes. So 10-month-olds don't appear to spontaneously understand that when the actor acts in this situation and when she pulls the cloth, that she's doing so in order to get the toy. Our group of 12-month-olds showed a different pattern of findings. In contrast, they looked longer to events in which the actor's goal had changed. So 12-month-olds appeared to understand, by the end of the first year of life, they appeared to understand that in this situation, what's important here is the goal object that the actor is going after, not the means that they're using to produce it. They understood that the actions on the cloth were one step to achieving a larger goal. So I've just told you about some developmental transitions that happen between 10 and 12 months of age in terms of infants' ability to understand action sequences. And the next question that we had is, what is the relationship here with infants' ability to produce these sequences? We know that between 8 and 12 months of age, infants start to reliably solve these sequences and appear to do so in a way that seems quite intentional. And so we wanted to know whether the ability to solve the sequence might relate in some way to infants' understanding of the sequence. Okay. So in addition to giving infants the visual habituation paradigm, we also gave 10-month-olds a task where we asked them to solve the cloth pulling problem in their own actions. Experimenter laid out a cloth, put a toy out of reach.
Good job, you got it.
And let infants, if they were so inclined, pull the cloth in order to get the toy. So what we were trying to measure here was how good infants were at solving this task in their own actions. And what we found is that for our group of 10-month-olds, some of them were really good at solving this task. Some of them produced solutions that looked like that on just about every trial. Other 10-month-olds, however, were not so good at solving the task. So they might do things like try to reach directly for the toy or play with the cloth, but they weren't producing the type of solution that I've just showed you there. What we wanted to know was whether infants' ability to solve this sequence was in any way linked to how they performed on the habituation task. So we took our group of 10-month-olds and we split them into two subgroups. The infants that are labeled planful here are the ones who were really good at solving the cloth pulling task in their own actions, the good cloth pullers. And the non-planful infants were the ones who were not very good at solving the task in their own actions. And what we found is different patterns of results depending on how good infants were at solving the task themselves. So the planful infants looked a lot like the 12-month-olds. They looked longer when the actor's goal object had changed versus when the means had changed. The non-planful infants actually showed the reverse pattern of findings. So what these findings suggest is that there's a tight linkage between infants' ability to produce complex actions and their ability to understand them. As infants become better at performing complex actions, they become better at understanding them. One of the ways that we followed up on this research is by taking 10-month-olds who aren't very good at performing complex actions and providing them with training experience doing so, and then looking to see what the consequences were for their understanding of other people's actions. And what we found is that this training experience is quite beneficial in terms of changing infants' understanding of other people's actions. So for the first part of my talk, I've discussed how infants' experience producing action is playing an important role in their understanding of action. And what I want to do now is I want to switch gears a little bit. And I want to talk about how infants start to develop an understanding of goals that is more sophisticated than what we've just seen. So the studies that I've just told you about are about infants' ability to understand goals as they play out in action. But of course, goals are also part of the mind. That's how we understand them as adults. And we also understand that goals tend to stem from certain characteristics of individuals. So for example, we think that the preferences that we hold, if we prefer one object to another, generate, in a sense, our goals. And this is part of what researchers typically refer to as having a theory of mind, an understanding of different internal states and how they relate to dispositions and individual characteristics. So what I want to do now is share some research in which we've looked at infants' ability to understand preferences. So one key aspect for adults of understanding preferences is understanding that they are subjective. They're individualist in nature. So imagine an infant who sees his mom and his dad in the kitchen milling about the kitchen. The infant sees dad walk over to a bowl that contains apples and oranges, and dad carefully inspects the bowl, the contents of the bowl, and then deliberately selects an apple and takes the apple and takes the bite out of it. And now along comes mom, and she does the same thing. She goes over to the bowl, she inspects the contents, and she picks up an orange, and she starts to eat the orange. And the infant sees this repeatedly over different days. Now, for the infant to understand what's going on here, they have to understand that different people can have different preferences, that mom can like one thing and dad can like a different thing. So in the next study that I'll tell you about, that was exactly our question. Do infants understand that different people can have different preferences? So here's how we asked that question. We used the habituation paradigm, and in this paradigm, we had two actors sit side by side at a stage, Monica and Sarah, who are in the audience tonight. And during the habituation event, only one of the actors acted, so in this case, Monica. And what Monica did is she looked at both of the toys as though she was considering them, and then she picked up one of the toys and she smiled, indicating her preference for that particular toy. And we show babies that event again and again, of course, until they got bored. Now, when the display was hidden from view prior to the test trials, we made two critical changes this time. We not only reversed the locations of the toys, but we also changed the person who was acting. So on the test trials, instead of having Monica act, we had Sarah act. On the test trials, what Sarah did is she either pursued a different goal as Monica using the same movement, or she used a different movement to pursue the same goal that Monica had previously. Now, the idea here is that if infants understand that preferences are individual and people can have different preferences, then they shouldn't really show any difference in looking times to these two test events, because, of course, Monica's preferences aren't necessarily meaningful for Sarah's preferences. In contrast, if they think that preferences bleed across people, that they transfer across people, you might expect longer looking to the event in which the goal changes. And we tested 8 and 10-month-olds in this study. So here are 8-month-olds looking times to the test event. And what we found is that 8-month-olds showed a non-significant preference for the event in which the actor's goal had changed. What this suggests is that, if anything, 8-month-olds have the assumption that preferences transfer across people, which is, of course, different than how adults think about preferences. 10-month-olds, on the other hand, looked directly equally at the 2 test events. They were equally interested whether she pursued a new object or produced a new movement. And what that suggested to us is that 10-month-olds don't automatically ascribe one person's preferences to another person. They're savvy in their ascription of preferences. They understand that they're bound to individual identity. The next question that we had was whether infants could also appreciate something else that is important to understanding preferences for adults. So because we think that preferences are somewhat stable and enduring, we don't assume that they're tied to anything about a person's superficial perceptual appearance. So if we think that Monica prefers frogs to cars, it doesn't matter whether Monica's wearing a blue shirt or a yellow shirt or a red hooded sweatshirt for that matter, right? We think that preferences are tied to individual identity, not perceptual appearance. So to ask this question, we started by showing infants exactly the same event that we did in the prior study. Monica looked at the 2 toys, considered them both, picked up one of the toys, and smiled, indicating her preference. Now, after infants got bored with seeing that event and the display was hidden from view, we again made 2 changes. This time what we changed is the location of the toys, and we also had Monica, who was still acting during the test trials, so same actor across the habituation and test trials in this study, wear a new shirt. And Monica, on the test trials, either pursued a different goal than she had previously using the same movement, or produced a different movement towards the same goal. Now the question here is, will infants understand that just because she's wearing a different shirt, that doesn't have any consequences for her preference? If they do, we would expect them to look longer when her preference has changed. They should be surprised or interested that her preference has changed. And again, we tested 8 and 10-month-olds in this study. So here are 8-month-olds looking times the 2 test events, and what you can see here is that infants at 8 months of age looked equally to both of those changes, a change in a movement and a change in the goal. So that suggests that when the actor's shirt changed, they weren't able to generalize the preference across that change. 10-month-olds, in contrast, showed a different pattern of findings. They looked longer when the actor's preference had changed, suggesting that they appreciated that just because her perceptual appearance has changed, just because she's wearing a new shirt, that doesn't have any consequences for her preferences. So what these findings suggest is that by 10 months of age, infants understand that preferences are stable across a change in superficial perceptual appearance. They also understand that different people can like different things, that there's no accounting for taste. Okay, so this brings me to the sort of last set of studies that I'm going to tell you about this evening. And in this set of studies, we wanted to ask the question of what sort of developmental achievements might be related or might be driving to this understanding of preferences, this changes in infants' understanding of preferences between 8 and 10 months of age. And we focused here on infants' language comprehension abilities. We know that between 8 and 10 months of age, there are rich developments in infants' ability to comprehend words. And given the sort of confluence between the changes that we see in infants' understanding of preferences between 8 and 10 months and their understanding of words between 8 and 10 months, we sought to investigate whether those abilities were related. So there were 2 reasons why we thought that language comprehension might be important for understanding preferences. One reason was that language requires babies to start thinking in abstract terms. Words are by their very nature abstract. And if you think about it, preferences and the way that they relate to goals, understanding that requires a high degree of abstraction. So the fact that they relied on this common cognitive component, we thought might mean that the 2 were linked. Another reason that we thought that language might play an important role in infants' understanding of preferences is because as adults, we use language accompanying action to figure out what exactly people are doing, what exactly is going on. So let's go back to this example where mom is in the kitchen and she selects an orange over an apple. And let's say we just see this once. And let's say we either see mom select the orange without saying anything, or we see her select the orange and say, "I love oranges," when she selects the orange. Well, in the latter case, where she's produced this language that gives us clear evidence of her preference, we would say, well, clearly this preference is enduring. There's something stable about it, right? In the former case, we might think, hey, it could be kind of random. Maybe it was a random once-off thing. In the latter case, when language is preference, we have increased confidence that this is a real enduring preference. So in the next study that I'll tell you about, the last study that I'll tell you about, the question that we asked was whether infants' language comprehension might play a role in their understanding of preferences. So in this paradigm, what happened was that infants saw an actor in the habituation trials in one room. And during habituation trials, she considered both objects and she picked up one of the two objects. And there were two different conditions in this study. We only tested 10-month-olds because of the prior transition that we'd found in understanding of preferences between these two ages, 8 and 10 months. In one of the conditions, what the actor did is after she picked up the toy, she just made a general remark about the object. She said, look, wow. In the other condition, what she did is after she picked up the toy, she made a preference statement. So she either said, I like frogs or I like cars if she was holding a car. Now, we wanted to make this paradigm one step harder for infants. So the way that we did this is that we made two changes from habituation to test trials. We switched the locations of the toys, that's our typical change, but we had test trials take place in another room. So what this means is that for infants to understand this event, they have to understand something more sophisticated about preferences, that preferences endure across contexts, right? That's something that we think as adults. We don't think that a preference for tea over coffee just means a one-time liking of or selection of tea over coffee on a late Saturday night in the middle of July, right? We think that there's some cross-context stability here. So test trials took place in another room, and again, on some of the test trials, the actor showed a new preference. She pursued a different goal object with the same movement that she had previously. On the other trial, she produced a different movement, but she went after the same object that she had initially. So the expectation here is that if infants transfer the preference across a change in room, they should look longer when the preferences changes on the different goal events. So again, these are 10-month-old infants, and here's infants' performance in the general remark condition. And in this condition, what we found is that infants didn't discriminate the test events. They looked equally to both of the test events. What this suggested to us was that when the presenter says, look, wow, they don't spontaneously expect her to pursue the same object in a new room. They don't necessarily think that her preference will extend to a new context. In contrast, infants in the preference statement condition, the condition in which the actor said, I liked cars or I like frogs when they picked up the object, showed a different pattern of results. They looked longer when the actor's goal had changed. And what this suggested to us is that the presence of language in this paradigm enabled infants to transfer the preference from one room to another, to extend it across contexts. And we also found in this study that infants' performance on this task was highly related to measures of language comprehension. So infants who were really good at understanding words were the ones who were really likely to transfer the preference across a change in context, and infants who were not so good at understanding words were less likely to do so. So what these findings suggest is that language comprehension skills might play an important role in infants' ability to understand goals at a higher level in terms of driven by the preferences that people possess. So to recap, what I've told you is that in the first year of life, we see rich developments in infants' ability to understand other people's goals and intentions. They go from understanding simple actions to understanding action sequences to understanding people's preferences, having a higher level understanding of goals. And over the same time course, the developmental achievements that we see in infants' ability to produce action and their language comprehension are linked to the rich changes that we see in infants' understanding of goals and intentions. And part of the reason that these results are so interesting to developmental psychologists within the field is they paint a particularly rich picture of what infants understand about other people's behavior, a much richer picture than we had 10 or 15 years ago. Now, one question you might have is, what are the implications of this work? Why does this matter to the real world? Well, I think there are 3 reasons that these findings matter to the real world. The first reason has to do with learning mechanisms. So anyone who is interested in early learning wants to know how learning is happening. And what these results suggest is that there are 2 predominant ways that infants learn about the world in the first year of life. One way they learn about the world is through hands-on experience, through acting in the world. Another way that they learn about the world is through the language that they're exposed to and their ability to understand that language. So we've learned new information about developmental mechanisms, learning mechanisms that drive developmental change. The other reason that these findings are important is because we know from some recent research that how infants perform on these tasks that I've told you about, these habituation tasks that measure their understanding of other people's goals, actually predict developmental outcomes. So how an infant performs on these tasks predicts their theory of mind skills in preschool. You'll hear more about theory of mind from Rebecca. And this, in turn, theory of mind performance predicts things like social competence, how adept children are at acting in their social world during the school years, and their school readiness, their ability to sit down and participate in the school environment. Finally, there's a number of people who have suggested that the ability to understand goals and intentions, and in particular, their ability to understand goals and intentions at this kind of higher, more sophisticated level in terms of preferences, in terms of theory of mind, may be a uniquely human achievement. So by studying human development and learning about what infants know, we can learn about some of the things that make us uniquely human. Thank you.
At this point, if there are folks that have questions, you might want to move to the sides where we have microphones. Okay. And in the meantime, I guess I have one question for you. I'm just wondering also about the implications of your work for sports training. We often think about how, in order to teach somebody a particular skill, it's the muscles that need training and developing.
Right.
Maybe an understanding of the consequence of the movement.
Right.
May also lead to greater training.
Right, sure. And I think it probably depends where someone is in the learning process, right? So if you're trying to learn to perform a tennis serve, something I've been trying to do for a very long time, at first you're just focusing on the movements and the muscles, but over time you start to look down line and focus on the goal, like not only making contact with the ball, but where you want to get the ball on the court, right? So I think it is important to keep that in mind, and our ability to do so changes as a function of the learning process.
Maybe that's related to the fact that once you do learn it, and then you go back and think about your movements,
it messes you up.
Well.
Right.
Okay. I think we had one question over here.
That's very, very fascinating. Thank you.
Thank you.
And I hope my question will challenge you because you challenged me a little bit.
Okay.
Here. So I'm gonna restate what I think I understood. You're trying to explain infants' thinking by observing actors, and then inferring statistically their understanding of the actors' goals by measuring the infants' reactions. But you didn't address the infants' goals and their preferences in their reactions. So the question is, do the infants' preferences and goals precede or dominate cognition and complex understanding? And so, for example, what got me challenged, we could set up a relatively simple experiment from what you've done. For me, it wouldn't be quite so simple. We could set up a relatively simple experiment to examine infants' preferences. So we could take we could look at two goals. An infant's goal or preference to either perform and please others or themselves, or on the alternative, their goal to solve something or to mimic behavior. And so then, from there you could add other conditions, and this is what really got me early on is in thinking about the infant's reactions to observations. Were they hungry? Were they tired?
Sure.
Did you take those things into consideration?
Yeah, great question. Okay, so there's a whole bunch of parts to your question. I want to start with the first part, which is about the role that infants' own goals and preferences might play. And I think they do and they don't. So they do definitely play a role. I think one of the arguments that we're trying to make is infants' ability, in a sense, to enact their goals helps them to understand the goals of other people. And of course, I'm talking about goals in terms of, for example, achieving a toy versus kind of the more higher level or abstract goals that you were talking about, right? The interesting thing about the higher level understanding the preferences is that one of the things that we've done is tested whether when babies see this event and then they're given the opportunity to select between the toys, whether they perform better if their preference matches the actor's preference. And in that case, in the case of the higher level understanding, it doesn't seem like there's any there's any intersection. So I think in understanding certain parts of action, goals play an important role. And in understanding other parts of action, maybe at a higher level, they play a less important role. So that was kind of the conceptual part of your question, right? And then there was another part of your question that was about the state of the infant, right? So what we hope for is that we test infants in the very best state that we can have them in. So we encourage parents to bring them in that way, right? Of course, we can't guarantee it. And that's part of the reason that infant research is so labor intensive, because you need a large pool of participants, because some of those participants will start the study and decide they don't like it and they'll drop out. They're not as conformist as adults, right? So we need a very large pool of participants in order to be able to do that. And what we're primarily looking at is age-related changes. So we're averaging across infants as opposed to, for a particular infant, trying to figure out what does this particular infant know, right? But that is one of the limitations of infant research, is that infants aren't always in an ideal state for being tested. Yeah.
You said that there is a significant noticeable difference between how different kids react to different to experiments. So there is some that, as you said, some 10 months old behaves like more like 12 months old. What I want to ask, is there any early signs of looking at the same kids, infants at 3 months or 6 months age, we can predict how they would behave at 10 months and so on? Like, is it dynamic? Is it like a stationary dynamic, or it can change unpredictably after 6 or some kind of point of
Good
developmental
question.
points?
Yeah, there's a lot of that research going on right now. And the paradigms that I told you about today are just one method for looking at early social cognition in infants. There's a range of different measures. You can look at infants' ability to imitate, for example. You can look at their ability to respond to social behaviors that an adult produces. And I think a lot of new research that's coming out suggests that measures that you get very early in life at 6 months of age on these simple reach and grasp tasks actually predict those later measures of social cognition, predict infants' imitative behavior, predict their responses to social behaviors produced by an adult. So it does seem as though there's some coherence here and some continuity in the types of things that we're seeing. And I think one of the exciting things is some of the research that's coming out now suggests that on these tasks at 6 months of age, you can often predict all the way out to 4 years of age on these more complex theory of mind tasks that Rebecca's going to tell us about. So that's pretty exciting. Yeah.
Hi, I just was curious about the second group of research that you presented, and talking about the planful versus non-planful infants.
Right.
And the first set you talked about the sticky mittens as being a way to foster the development of this kind of reaching behavior. Is there anything that you think, for one, distinguishes the planful from non-planful infants, and how you might facilitate that in terms of the cognitive growth that then implies?
Yeah, well, I can tell you about some of the methods that we have taken. So in another study, what we wanted to know is whether you could train babies to perform a complex action. And the action that we chose was one where babies had to use a toy cane, a novel tool that we created to get an out-of-reach toy. And we used that tool, even though it was hard to construct and kind of unusual and totally novel to infants, because we wanted to start with something that we knew infants had no experience with, right? So unsurprisingly, when we brought infants into the lab and tried to have them use it, they were not very good at it at all. And what we did then is we created tutorials for infants to help them get better at it. And the tutorials that we used varied as a function of the infant. So some infants had problems with it because they, for example, weren't sure of the motor actions that one should perform in order to use it, or that it could even be used to get a toy. So then an experimenter might help shape the baby's motor actions in order to help them pull the cane in order to get the toy. Some of them had a hard time continuing to attend to the goal, so we might use kind of attentional direction to attend them to the goal. And so we used a variety of different methods that were individually specific, and infants got better as a result of that exposure. And we found then that that had consequences for infants' ability to understand that cane pulling action when it was performed by another person. The interesting finding from that study that came out as well was that the active experience was necessary. The active experience using the cane was necessary. When we did a matched observational condition where the baby only got practice watching, that wasn't sufficient to help them to understand cane pulling by another person. Yeah.
Thank you.
What did you say was a uniquely human ability, and
Yeah.
why did you say it was, did you do this with animals?
I didn't personally, but of course there's a lot of comparative work that uses similar and somewhat different paradigms to test non-human primates. And some of this work investigates exactly this question, that is, which of these abilities do we share with non-human primates and which of these abilities do we not, right? And one thing that may be uniquely human, although of course this is as in, as any question is debated in science, this question is debated, is whether the ability to understand goals, intentions, mental states at a higher level, right? So understanding how preferences linked to goals is sophisticated because it involves understanding this causal connections that the preferences that we possess in a way drive our behavior. Those are the things that some people have argued may be specific to humans that we alone may possess. So by looking at this research, not just on its own, because of course I'm only talking about infants, but in comparison to some of the other research that's been done with non-human primates, it might be possible to identify, well, what makes us special? What makes us uniquely human?
Thank you again for attending tonight.